Okay, today we're in section 8.8, Systems of Linear Equations. Well, we've been dealing with linear equations pretty much the entire chapter, so that's nothing new. Except in today's lesson, it's a system of linear equations, meaning I'm going to be looking at more than one and trying to find a solution that fits in both equations. All right, so a couple things you need to know. All right, a system of linear equations has two or more equations with the same variables, meaning one can't be x and y, the other one can't be c and d. It has to be the same variables. Okay, then I'm looking for the solution. The solution is an ordered pair. Okay, so there's the big one right there. It's an ordered pair. That's going to be my solution. That fits into each equation, basically makes each equation equal. All right, and we'll see how that works out in just a second. But what I have highlighted is what you need to make sure you write in your notes. All right, now that you have those definitions written down, I want you to go ahead and on your graph paper, I want you to graph both of these equations. So there's going to be 4 points total. Go ahead and graph both of these equations. All right, so the y-intercept for the first equation is at a value of what? Value of -4, so I plot my point. And then my slope is 2, so I go up 2 over 1, and I plot my point and draw my line. Okay, then my y-intercept for my second equation is at a 1, so I plot my point at the 1. And then that slope is -3, so I go down 3, 1, 2, 3, and I go over 1 again. So my point's going to be on the same point, and then I'm going to draw my line through there. The solution to this system of linear equations is the point at which the two lines intersect. It is that ordered pair. So what is the ordered pair that these two lines intersect at? What's going to be my x value? 1. And what's my y value? And so that's my answer. This is my solution, 1, -2. The point where the lines intersect is my solution. I write the ordered pair and I'm done. All right, in example 2 now. Okay, we're going to just look at, basically we're still trying to figure out what is the solution to this system of linear equations. But now these equations are going to look a little different. Now, without looking at the graph, I just want you to look at the equations. Look at the equations up here for a second. What do you notice about these equations? Anybody have any observations? They have the same exact slope. Now I know from previous lessons that equations that have the same slope they form parallel lines, right? So if they're parallel lines, as you can see in the graph, will they ever intersect? No. And since they'll never intersect, anytime I have a system of equations that form parallel lines, I will have no solution. No solution. All right, now unfortunately, you do have to graph this to show me that they're parallel lines, but then you're just going to say no solution. Remember, the solution is the point at which the lines intersect. If they never intersect, then there is no solution. All right, now I want to look at this system of equations. Okay, I have 2x minus y equals -3 and -4x plus 2y equals 6. What's the first thing that you notice, though, about these equations? They're not in slope-intercept form. So the first thing I want you to do on your paper is go ahead and write both of these equations in slope-intercept form. All right, so we go ahead and start off by starting to move the variables because we have to have it in y equals mx plus b form. Subtract 2x from both sides. Now, is this my answer, though? -y equals -2x minus 3? No, because of the negative that's attached to my y, I have to divide everything by -1. and y equals 2x plus 3. Then on my second equation, I add 4x. I'll change that in just a sec. Divide everything by 2, and y equals, oh look, ironically, 2x plus 3. So here's what this example is showing us. When I write my equations in slope-intercept form, and I have two equations that are exactly the same, I am going to have an infinite number of solutions. So if you ever have a problem like this where you have both equations the same, you are going to say infinite solutions. Infinite solutions. And it means this. Basically, any point on this line, any point. I mean, you can just start plotting points. Here, here, here. These are two lines that lie on top of each other. So there are literally an infinite number of solutions because you pick any point on this line and they both share that point, correct? Okay, so that's just basically a roundabout way of saying there are infinite solutions. All right, example 4 in this unit actually involves a graphing calculator, and I don't feel that it's necessary to cover that. Examples 1 through 3 are the most important parts of the lesson. So with that being said, that's everything you need to know for 8.8.